is really going through, you see. But when you put one next to the other, obviously the diameter of the circle is greater than the diagonal of the square hole. I did not stretch, let alone tear. And yet something larger goes through something smaller. You see, I can even pass it backwards from here, and it is really going through, as you can see. And what is going on? Large thing is going through a smaller thing. So how is this possible? Because you are such a nice bunch of people, I'd like to reveal the secret for free. Usually I pass around the hat. You see, when you fold the paper like this, the largest gap that I can take advantage of is this one, which used to be the diagonal of the square hole. But that's not all I do. I grab this sheet of paper, and then I twist. As I twist, you might see in the camera that the part of the paper is rising away from the two-dimensional plane into the three-dimensional remaining residual dimension. And as those two segments are aligned, I squash and crease. Then the gap that I have created is no longer the diagonal, but it's actually the sum of those two sides. And if you remember Pythagoras, you have gained an extra factor of about 40%, square root of 2 minus 1. So that's how you can pass this through. Although the square seems to be smaller than the diameter, the secret was to make a hole whose diagonal is shorter than the diameter, but whose sum of the two sides is longer. And you can see that this kind of thing was possible, although at first sight it was impossible, because we escaped into the ambient 3D and then came back down into 2D. And this extra freedom of going in and out is going to be really important.